Okay, so here we will look at how the velocity transformations can be obtained from the Galilean transformation, the coordinate transformations. So we start with the Galilean transformations and ask question, if you have some sort of a reference frame, say you have some sort of a particle which goes along some sort of a trajectory, and between any two adjacent points of the trajectory you would want to measure say x1 t1 and x2 t2, right? And similarly using a frame which is moving with respect to the unprimed frame, so let's call this frame S, and then you have the primed frame S prime, and then you have to measure the respective times and locations for the 2 points adjacent. So let's say those are x1 prime and t1 prime and x2 prime and t2 prime. Now we want to ask the question, if I am going to measure the velocity of this particular object, of course I need to take the change in the displacement divided by the change of time, so that can be defined as x2 minus x1 divided by t2 minus t1. So basically you will talk about these changes in the displacement and changes of time, right? So I will translate that into this velocity to this coordinate transformation in the following way. So any change in the coordinates x delta x prime has to be equal to delta x minus v delta t, and similarly any change in time delta t prime will be equal to delta t. So now let's calculate the velocities. So we will get delta x prime divided by delta t prime is going to be delta x minus v delta t